Hello, welcome to CREATA Classes. I am Gurmeet Singh and also welcome to our new series on Class 10th Chapter 9, Some Applications of the Trigonometry. And in this series, we will cover all these lectures using the power of visualization. Hope you will love our new way of teaching and the creative way of teaching. And apart from this lecture series, we also have a quiz and the PDF of the concept and formula list. Check the link in the description. And especially in this lecture, we will cover the NCERT example questions, question number 6 to question number 10. And again, do not underestimate the NCERT exercise questions. They are really very good. Okay. So without taking any further time, let's start with this lecture and best of luck. And here is the lecture. Question number 6. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks toward the building. Find the distance he walked toward the building. Interesting question. Firstly, let's observe the question. A boy is given and the height of the boy is given as 1.5 meter. So this is the boy, the height is 1.5 meter. Further, a 30 meter tall building is also given in front of that boy. And the angle of elevation from the eye of that boy to the top of the building is given in two different conditions. At first point, the angle of elevation from his eyes to the top of the building is given as 30 degree. What is angle of elevation? Angle of elevation is the angle between the line of sight and the horizontal line. Line of sight is a vision line wherever we are looking. So here this boy is looking at the top of the building. So this is the line of sight and this is the horizontal line. And this is the angle between the line of sight and the horizontal line. Note that the angle of elevation is with respect to the horizontal line. Don't be confused it with the vertical line, the common mistake done by the students. Further, in the first case, this angle is given as 30 degree. Further, in the second case, the boy started moving toward the building and after some time, this angle of elevation has been changed to 60 degree. In the first condition, the angle of elevation is 30 degree. In the second case, the angle of elevation is 60 degree. And we have to calculate the distance that this boy has walked toward the building. It means we have to calculate this distance. Let's mark the different points as A, B, C, D, E, F and G. It will be helpful. Here in this question, we have to find the distance EF, or we can say the distance AD, both are same. So let's approach this question. Here in this question, the height of the tower is given as 30 meter and the height of the boy is given as 1.5 meter. Height of the boy is AE or DF or BG. Here all these three line segments are equal to each other. So here we can say CG is equal to 30 meter, that is the height of the tower, and BG is equal to 1.5 meter, that is the height of the boy. So here can we say BC is equal to CG minus BG? We got BC as 30 meter minus 1.5 meter. That is equal to 28.5 meter. Got it? We have done the simple mathematics. We got BC as 28.5 meter. Further, here are we able to observe any right angle triangles in the given figure? Yes, we are having two right angle triangles in the given figure. The first triangle is triangle DBC, this triangle with the trigonometric angle at 60 degree. The second triangle is our triangle ABC with the trigonometric angle as 30 degree. And both the triangles are having the common side as BC, which is 28.5 meter. Let's aggregate both the triangles. For triangle DBC, our trigonometric angle is 60 degree. So BC is the perpendicular for this triangle, as this is the side opposite to trigonometric angle. Similarly, for the triangle ABC, our side BC is the perpendicular as it is opposite to trigonometric angle 30 degree. Both the triangles are having the common perpendicular, which is the side BC, 28.5 meter. For the triangle DBC, DB is the base, and for the triangle ABC, AB is the base for this triangle. The philosophy that we will use to solve this question is, firstly, we will calculate the base for both the triangle. We will calculate the distance AB from this triangle and the distance GB from this triangle. And in the question, we have to find the distance AD. So AD will be equal to AB minus BD. AB is a complete length and BD is a smaller length. So AB minus BD will be equal to AD. So this philosophy we will use. We will find the bases of both the triangle. So let's do so. Let's take the triangle DBC. Here perpendicular is given, trigonometric angle is given, and we have to find the base. So which trigonometric ratio we will apply? We will apply tan theta. Tan theta is equal to perpendicular upon base. So tan 60 degree will be equal to BC upon BD. And what is tan 60 degree? Let's refer the trigonometric ratio table. Tan 60 degree is root 3. So let's solve for BD. BD will be equal to 28.5 upon root 3. Okay. We got the base of one of the triangle. Let's go to the second triangle, the triangle ABC. In this triangle, again the perpendicular is given and trigonometric angle theta is given, and we have to find the base AB. So again we will apply tan theta. Tan theta is equal to perpendicular upon base. Tan 30 degree is equal to BC upon AB. And what is tan 30 degree? Let's refer the trigonometric ratio table. Tan 30 degree is 1 upon root 3, which is equal to 28.5 upon AB. So we got AB as 28.5 root 3. So we got base of this triangle. We got AB and BD. Let's find AD. AD will be equal to AB minus BD, which is 28.5 root 3 minus 28.5 upon root 3. Let's solve this. Let's take the LCM as root 3. Let's further solve it, the simple mathematics. On solving, we got AD as 57 upon root 3. Let's further solve it. Let's multiply the numerator and denominator by root 3. On solving, we got our answer as 19 root 3 meters. That is the distance between the 2 points, or the case 1 and case 2. AD we got as 19 root 3 meters. So that is the answer. The more you are able to visualize the question, the more easily you will be able to solve the question. So the core message to solve the height and distance question is the visualization. The more you are able to visualize, the more you are able to solve it. So we have done with this question. Let's move to the next question. Question number 7 is, from a point on the ground, the angle of elevation of the bottom and the top of a transmission tower fixed at a top of 20-meter high building are 45 degree and 60 degree respectively. Find the height of the tower. So this is a question. Firstly, let's observe the question. In this question, a building is given and the height of the building is given as 20 meter. So this is a building and the height of this building is 20 meter. Above this building, a transmission tower is fixed. This is the transmission tower. Let's assume the height of the tower as h, and in this question we have to find the height of this transmission tower. Further, it is given from a fixed point on the ground, the angle of elevation of the bottom and the top of the transmission tower are given as 45 degree and 60 degree respectively. It means from this point we are looking at the bottom of the transmission tower and at the top of the transmission tower. The angle formed when we are looking at the bottom of the transmission tower is 45 degree, and when we are looking at the top of the transmission tower, the angle formed is 60 degree. The angle of elevation when we are looking upward, and this angle is with respect to the horizontal line, and do not do the mistake of taking this angle with respect to the vertical line, the common mistake. Further, let's assume this point as point A, and also take the building as BC and the transmission tower as CD. We got 4 points A, B, C and D, and in this question we have to find the height of the transmission tower. So we have observed the question, we have visualized the question. This is the most important step. Let's move to the next step and apply the trigonometric formulas in the given scenario. Are you able to observe the two right angle triangle? The first right angle triangle is triangle ABC, this triangle with the trigonometric angle as 45 degree. And the second right angle triangle is triangle ABD, this right angle triangle. And the interesting thing is that both the triangle are sharing the common base. Here AB is the base for both the triangles and both the triangles are sharing the common base. This is important because we can apply the trigonometric ratio formula in both the triangle, and as both the triangle are having the common base, we can equate the output of both the triangle or use the output of the first triangle and apply the same in the second triangle. So in this line we will solve this question. Let's take both the triangle out of the given figure. Here in the triangle ABC, we are having our trigonometric angle as 45 degree and BC is the perpendicular as it is opposite to our trigonometric angle 45 degree, and BC is given as 20 meter, and AB is the base for this triangle. Further, in the triangle ABD, here BD is the perpendicular for this triangle as it is opposite to our trigonometric angle 60 degree. And this perpendicular, if you observe in the given figure, the length of this perpendicular is h plus 20. This perpendicular is composed of the height of the building and height of the transmission tower. The height of the building is 20 meter and the height of the transmission tower we have assumed as h. So the total height will be equal to h plus 20. So BD we got as h plus 20. Further, for this triangle AB is the base. AB is the base which is common in both the triangle. The strategy that we will use to solve this question is that we will apply the trigonometric ratio formula in the triangle ABC and we will find the base, that is the distance AB. The value that we got from the first triangle, that is the value of AB, we will put in the second triangle and again apply the trigonometric ratio formula in the second triangle. Only variable that is coming in the second triangle is h, that is the height of the transmission tower, and that is the missing dimension of this question. So you got the strategy, let's apply it. Let's apply the trigonometric ratio formula in the triangle ABC. Here perpendicular is given as 20, the trigonometric angle is 45 degree, and the missing dimension is the base AB. So what is the linking between the perpendicular and the base? It is tan theta, right? You're right, tan theta is perpendicular upon base. So tan 45 degree will be equal to BC upon AB. And we know what is the value of tan 45 degree? It is 1. Tan 45 degree case is very interesting, the value is 1. Here the perpendicular and the base will be equal to each other. Let's see. Further, here BC it is given as 20 meters. Let's put BC as 20. Let's solve it. We got AB as also equal to 20 meters. That is the base of this triangle. Got it? The angle is 45 degree. In case of 45 degree, the perpendicular and the base both are equal to each other. The same we have seen in the previous questions too. So we got the base or the side AB as 20 meters. Let's use this base for the second triangle too. AB is common in both the triangles. For the second triangle, the trigonometric angle is 60 degree. The perpendicular is h plus 20. And the base we just got as 20 meter. So again tan theta will be applicable as here the perpendicular and base are coming into the picture. Only tan theta is a linking between the perpendicular and the base. We got tan theta is equal to perpendicular upon base, that is tan 60 degree is equal to BD upon AB. Further, here BD is h plus 20 and AB is 20. And what is the value of tan 60 degree? Tell me, think. Tan 60 degree is root 3. Tan 30, tan 45 and tan 60, these three values you must know. Tan 60 degree is root 3. So we got root 3 is equal to h plus 20 upon 20. So we got h plus 20 is equal to 20 root 3. Let's solve it. We got h as 20 into root 3 minus 1. That is the answer of this question. The height of the transmission tower we got as 20 into root 3 minus 1 meters. Got it? That is the answer of the question. The more better you are able to visualize the question, the more better you will be able to solve the question. So we have done with the question number 7. Let's move to question number 8. Question number 8 is, a statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point, the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. So this is the question. Firstly, let's observe the question. A statue of height 1.6 meter is given in the question, and this statue is standing on the pedestal. The height of the statue is given as 1.6 meter and we have to find the height of the pedestal. Let's assume the height of the pedestal as h. Also a point is given on the ground. Let's take this point as point A. From this point A, the angle of elevation of the top of the statue as well as the top of the pedestal is given. Angle of elevation when we are looking upward with respect to the horizontal line. The angle of elevation when we are looking at the top of the statue, it is given as 60 degree. And the angle of elevation when we are looking at the top of the pedestal, it is given as 45 degree. And in this question we have to find the height h, that is the height of the pedestal. Let's take the other points as B, C and D. We are having total 4 points, A, B, C and D. BC is the height of pedestal that we have to calculate, which is h, and CD is the height of the statue, which is given as 1.6 meter. So this is the scenario given in the question. Let's proceed with the solution. In this question, are you able to observe the two right angle triangle? The first triangle is a triangle ABC with the trigonometric angle as 45 degree. And the second triangle is triangle ABD with the trigonometric angle is 60 degree. So these are the two triangles, and the interesting thing is that both the triangle are sharing the common base, that is AB. You can correlate this question with the previous question in which also the base is common in both the triangle. The same strategy we will use here also. Let's take these two triangles out of the figure. In the triangle ABC, our trigonometric angle is angle 45 degree and the perpendicular is BC as it is opposite to our trigonometric angle, which is 45 degree. And AB is the base for this triangle. Further, in the triangle ABD, the side BD is a perpendicular as it is opposite to our trigonometric angle 60 degree. And if you observe in the main figure, BD is the combination of the height of statue and the height of pedestal. The height of statue is 1.6 meter and the height of pedestal is h. So we can say the total distance BD will be equal to h plus 1.6. We have just added the height of both the given component. So the perpendicular for this triangle is BD, which is h plus 1.6, and AB is the base of this triangle and base for both the triangle is common. The strategy that we will use is we will apply the trigonometric ratio in both the triangles and we will find the base of both the triangle, that is AB, and we will equate the output, that is the bases of both the triangle, to get our height h, that is the missing dimension in the given question. So let's see how we actually approach this question. Firstly, let's check the triangle ABC. In this triangle, the perpendicular is h and the base is AB. So what is the linking between the perpendicular and the base? The linking is tan theta. Tan theta is equal to perpendicular upon base. So here tan 45 degree will be equal to BC upon AB. BC we have assumed as h, that is the height of pedestal. And what is the value of tan 45 degree? It is 1. So we got 1 is equal to h upon AB. So h is equal to AB. We got the height of the pedestal is equal to the distance AB. Further, we will use this value of AB as h in the second equation or in the second triangle. So let's take the triangle ABD. Here the perpendicular is h plus 1.6 and the base is AB. Here also we will apply the tan theta. Tan theta is equal to perpendicular upon base. So tan 60 degree we got as BD upon AB. BD it is h plus 1.6 and what is the value of tan 60 degree? It is root 3. Further, just now we got AB is equal to h. So let's replace here AB with h. We got our equation as root 3 is equal to h plus 1.6 upon h. In this equation only the variable is h. So let's solve this equation to find the value of h. Let's solve it. Simple mathematics. We got h is equal to 1.6 upon root 3 minus 1. Let's further solve it and multiply the numerator and the denominator with root 3 plus 1. Here root 3 minus 1 into root 3 plus 1, it is resembling a minus b into a plus b, which is a square minus b square. That is root 3 square minus 1, which is 3 minus 1, which is 2. So we got our h as 1.6 upon 2 into root 3 plus 1, which is 0.8 into root 3 plus 1. That is the answer, that is the height of the pedestal, 0.8 into root 3 plus 1 meter. So this is the answer of this question. The better you are able to visualize it, the better you are able to solve it. So we have done with the question number 8. Let's move to question number 9. The angle of elevation of the top of the building from the foot of the tower is 30 degree and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, find the height of the building. So this is the question. Let's observe this question. In this question, a tower and the building is given. The height of the tower is given as 50 meter and the height of the building is missing, that we have to calculate in this question. Further, the angle of elevation of the top of the building from the foot of the tower is given. It means we are looking at the top of the building from the foot of the tower. The angle formed is 30 degree with respect to the horizontal line. Further, the second angle of elevation is also given. In this case, we are looking at the top of the tower from the foot of the building and the angle formed is 60 degree. Got it? When we are looking at the top of the building from the foot of the tower, the angle formed is 30 degree. And when we are looking at the top of the tower from the foot of the building, it is 60 degree. Got it? So this is the scenario given in the question. We have to find the height of the building. So let's proceed. Let's mark the point as A, B, C and D. AB is the building and CD is the tower. Here are you able to observe the two triangles in the given figure, the two right angle triangle, the triangle ABC and the triangle BCD. These two triangles are the right angle triangle and both the triangles are sharing the common side BC. That is the base of both the triangle. In the triangle ABC, the trigonometric angle is 30 degree. AB is the perpendicular as it is opposite to trigonometric angle and BC is the base for this triangle. And for the triangle BCD, CD is the perpendicular as it is opposite to trigonometric angle 60 degree and BC is the base of this triangle. BC is common in both the triangles. That will help us in solving this question. Firstly, let's take the triangle DBC. Here we will use tan theta as it will link the perpendicular and the base. Tan theta is equal to perpendicular upon base. So tan 60 degree will be equal to CD upon BC. CD is 50 meter, that is given, the height of the building. What is the value of tan 60 degree? It is root 3. So on solving, we got BC as 50 upon root 3 meter. We got the BC, that is the base of this triangle. Further, let's take the triangle ABC, which is sharing the common base BC. We can use the value of BC that we got from the first triangle in the second triangle. Here the base of this triangle is BC, which we have just calculated as 50 upon root 3. And AB is the missing dimension. Our trigonometric angle is 30 degree. So here also we will use a tan theta which will link the perpendicular with the base. So tan theta, which is perpendicular upon base, will be used. Tan 30 degree will be equal to AB upon BC. BC let's replace with 50 upon root 3. And what is the value of tan 30 degree? It is 1 upon root 3. Let's solve this equation. We got AB as 50 upon 3 meter. That is the answer of the question. The height of the building we got as 50 upon 3 meter. Got it? This is the answer of the question. We have done with the question number 9. Let's move to question number 10. The question number 10 is, two poles of equal heights are standing opposite each other on either side of the road, which is 80 meter wide. From a point between them on the road, the angle of elevation of the top of the poles are 60 degree and 30 degree respectively. Find the height of the poles and the distance of the point from the poles. So this is the question. Let's observe the question. This question is talking about two poles on the either side of the road. So this is a road in between the two poles. The length of the road is given as 80 meter. The height of poles are given as equal to each other. Let's assume the height as h. So the height of both poles are equal to h meters. Further, a point is also given on a road. Let's assume this as a point. From this point, the angle of elevation of the top of the poles are given. It means from this point, we are looking at the top of the pole and the angle formed are 30 degree and 60 degree. If we are looking at the left hand side pole, the angle forming is 30 degree, and if we are looking at the right hand side pole, the top of the pole, the angle formed is 60 degree. And in the question we have to find the height of the poles, that is we have to calculate the distance h or the length h, and also we have to find the distance of the point from the pole. It means we have to find this distance and also we have to find this distance. So this is the scenario given in the question. Let's approach the question. Let's mark the point as A, B, C, D and E for easily application of the trigonometric ratio formulas. Here are you able to observe the two right angle triangles? The triangle ABE and the triangle DCE. These are the two right angle triangles in which we will apply the trigonometric ratio formula. In the triangle ABE, 30 degree is the trigonometric angle. So the side AB will be the perpendicular and the side BE will be the base. Similarly, in the triangle DCE, angle 60 degree is a trigonometric angle. So DC will be the perpendicular and EC will be the base for this triangle. The approach that we will use is, firstly we will apply the trigonometric ratio formula in the triangle ABE and we will calculate the distance BE. That will be obviously in the terms of H. Further, we will also apply the trigonometric ratio formulas in the triangle DCE and we will calculate the distance EC. That will also be in the terms of H. We will get BE and EC and the total length of the road is given as 80 meter. It means BE plus EC is given as 80 meter. We will calculate BE separately and we will also calculate EC separately. We will add them and we will equate it to 80 meters. Through which we will get an equation in which only one variable will be there, that is H. So this approach we will use. Let's see how we solve this question. Firstly, let's apply the trigonometric ratio formula in the triangle ABE. Here the perpendicular is H and base is BE. We will go with tan theta as it will link the perpendicular with the base. So tan theta will be equal to perpendicular upon base. Tan 30 degree will be equal to AB upon BE. AB is H and what is the value of tan 30 degree? It is 1 upon root 3. So let's solve for BE. We got BE as H root 3, that is the base of this triangle. Got it? We got one component BE. Let's also apply the trigonometric ratio formula in the second triangle and let's calculate the distance EC. Again we will use the tan theta which is perpendicular upon base. Tan 60 degree will be equal to DC upon EC and DC is H meters, that is the height of the pole. And what is the value of tan 60 degree? It is root 3. So we got the value of EC as H upon root 3. That is the second component of the road. We got BE and EC, that are the two components of the road. BE plus EC, it is equal to BC, that is the total length of road which is given as 80 meter. Let's put the value of BE and EC. We got H root 3 plus H upon root 3 is equal to 80. We got this equation that we are talking about. The only variable in this equation is H. We can easily solve this equation and we can get the value of H. Let's see. Let's take the LCM as root 3. We got 3H plus H upon root 3 is equal to 80. Let's further solve it. We got 4H is equal to 80 root 3. So H is equal to 20 root 3 meters. H is the height of the pole. So we got the one part of the question, that is the height of the pole, H as 20 root 3 meters. The second part of the question is demanding the distance of the point from the poles. It means we have to calculate BE and EC. BE we have already calculated as H root 3. Let's replace H with 20 root 3. On solving, we got BE as 60 meters. Next, let's go for EC, which we have calculated as H upon root 3. Let's replace H with 20 root 3. On solving, we got EC as 20 meters. So we have solved this question. We have solved the question number 10. The more easily you will be able to visualize the question, the more easily you will be able to solve the question. Understand the power of visualization in mathematics. So students, we have done with this lecture. Hope you have enjoyed our new and creative way of teaching. If so, like the hit button, subscribe to our YouTube channel and also share this video with your friend. And do not forget to download the PDF of the concept and the formula list, and also check the link to the quiz in the description. So that's it for this video. Thank you very much for being with CREATA Classes. Bye for now. Best of luck and have a great day.